Good afternoon, everyone. Welcome to Engineers Connect community and the online live webinar on exploring and unfolding computer vision as an indispensable technology. And our today's speaker is Mr. Utsab Ray. He is our managing team lead and core team member at Engineers Connect, along with nationwide speaker and technical trainer. So today we will kickstart our session on a very emerging topic about computer vision, how they are getting significant, and how they cost in society from their very inception. Our speaker is a nationwide speaker, and we received overwhelming responses since last session. Those who missed our previous sessions can check on our YouTube channel, Engineers Connect, and also I will share the link for the previously held sessions in the chat box. It is our privilege that we are again back with a session to fulfill the needs of the students across nation to again conduct the webinar on topic that they suggested. Mr. Utsav, handing it over to you. Mr. Utsav, are you there?
Hello, am I audible? Hello.
Yes, Utsav, you are audible.
Actually,
You can
yeah,
consider.
thank you so much. Actually, it was taking time to connect. I'm just sharing my screen and I'm just
Yes,
starting.
yes, yes.
Yeah, so once again, very good afternoon to everyone present here. So today, just we will be conceptualizing a throwback what we have received in our last session about many of the students have told us that they wanted a session on the basis of computer vision. So previously in the session of artificial intelligence and machine learning, what we have correlated that there are various kind of emerging topics and various kind of emerging technologies that are getting diversified day by day. So computer vision is turning up to be one of them that is facing a wide area of application in immense number of fields, starting from medical, okay, sports, robotics, automation, and everywhere it has its application in a diverse manner. Okay, so this illustration is a basic keynote that how it correlates each and every pattern in its own way. So computer vision, you can see just a Venn diagrammic representation that it has a relation with image processing. Okay, in medical science and in any images, you can find that image processing bears a quite significant relation with computer vision. Okay, in artificial intelligence, in various field of artificial intelligence, starting from face detection, starting from any detection of any hand or any conversion on anything, artificial intelligence will find the use of computer vision. Okay, nowadays in mathematics, in higher algebra or in higher probability, when the use cases are turning up to be the caption of any recognition of any video or any images or any objects in basic sciences like physics and mathematics, computer vision is turning up to be an emerging one. Okay, in signal processing, computer vision finds the application in major type of communication systems, where the modulation part, or where to remove all the noise, actually the electronic system turn out to be fatal. So in that case, with the help of the technologies of computer vision and by the implementation of all those techniques, we can use to recover that particular signal, how it can be transmitted and how it can be traveled from one source to another. So this is what the computer vision can finding its significance it all over, like from pattern recognition to image processing to artificial intelligence, mathematics, physics, and everywhere. Okay, so now, so today actually what we will be covering up, we will be just starting up with a basic of computer vision, that what is computer vision is all about. Okay, a brief history, just a brief to introduce you all about that, what is computer vision is, how it came into significance. Okay, now we will be just correlating the human vision, that how the computer vision is different from human vision, or what are the similarities rather. Okay, that both analogies will be explained to you. Okay, and why it is turning up to be indispensable, because since computer vision, everyone in every universe, in every industries, in every field, computer vision is being used as a cup of tea. So why is it so? Because some keynote things or some highlighting features are there. Okay, and the application area of use case is most often, while I'll be starting off with this, and I'll be just starting off with OpenCV, because for the application cases, many of us will find that OpenCV is a library. Okay, we'll be using in Python. Okay, and while using that in Python, how to write the code and how to represent that through OpenCV mode, I will be just demonstrating to you all. Okay, and the image processing part, how that significance of image processing is related highly with OpenCV. How can we process several kind of images? I was just before this session, I was just preparing one file of Python file of programming based on was coding part, that how to process several kind of images. Okay, with the help of Python languages. Okay, age detection. Okay, these are all the application. So I will be just giving you a basic illustration through Python as well, that how these things are correlated in our real lives. Okay, because we all see things that are around our perception. So when we can analyze and study all those things, then the things becomes much more easier to us, that yes, this thing is this. Okay, and mini hands-on project are basically, I will be just giving you one topic. Okay, what we all can study throughout this session, and what the techniques are, we all can go through that. Okay, so computer vision is basically the science and technology of machines that see, right? Humans have eyes, computers can also see with the help of their eyes. So what is their eyes? That is the camera. Okay, coming to that, it is basically concerned with the theory of building artificial systems that obtain information from the images, right? Because in this present globalized world, and according to industry 4.0, what the things are turning up, basically everything is being turning up into artificial mode. Why? Because we are trying to reduce the error that human beings make, because the less the error human beings make, the more precise the system will behave.
Utsab, you are not audible to us.
Hello, hello.
Yes, now you are audible.
Yeah, so last slide was audible. Is this slide was audible?
Yeah, a bit. It was just completed halfway.
Okay, okay. I am just starting it from the very outset. So basically, computer vision is basically the way of correlating the science and technology of machines that can see, right? So what humans can see with the help of their eyes, right? So computers similarly, they can visualize with the help of some external artificial mode. So we can consider that as a camera, as a scanner, or anything else. Okay, and it is basically concerned with the theory of building artificial systems. So according to, I have already told that according to industry 4.0, or any other modes that are revolutionized in our globalized world, right? Artificial systems are getting a major significance. Why is it so? Right? Because to minimize human error, absolutely that, and to increase the coherence of any precision and accuracy as well from the images, from for any artificial system, because human beings can make errors, right? There are errors due to system, there are errors due to environment, there are errors due to any other circumstances. But if human beings try to develop any artificial system, then that responsive system can turn up to be an instrumental one to solve all the problems that are related to our modern world. right? So that is why computer vision came into existence, because visualizing things and thinking it beyond any perception bears a major difference. So a vision can help to signify, to realize, to understand, and to process everything that are being placed in front of the world. And the particular image data can take many forms, such as video sequence, okay, images, or multiple cameras, or any multidimensional data from any scanner. Okay, not only medical scanner, but any scanner. Okay, you can take a scanner from any Xerox, from any printout, or anything else. Okay, that all are acceptable. Okay, so basically, how does it work? Since it is a subfield of artificial intelligence, so the founder of artificial intelligence is basically to train and test, right? From the features, we will be training the data set, particular data set to the machine, and the machine will respond. It will be becoming responsive one. That's the basic significance. So this illustration shows that we human beings, we visualize from our eyes. And for an example, if you take a fruit, for an example, if you take an apple, right? So what are the features of an apple? Its color, its shape, okay, how it look like, its tree, and everything else. So these are all the parts of that feature, right? So that features are being fed to the brain. And what that brain now does, the brain gets trained that yes, this is an apple. How it looks like, this is the feature, this is a structure, this is a dimension. So in a similar manner, when we think about computer, we are feeding the input through a sensing device. Okay, so if you consider a sensing device, it senses the features only, the features, namely the color, okay, the feature, the dimension, okay, and what are its contents. So to more precise or to more extent how much we can go, the feature can be the same one, right? And now it is being fed to the machine. So machine is the interpreting device. So what the interpreting device does, the main functionality and the main topology of the basic algorithm is being trained in the interpreting device. And what that algorithm does, the algorithm now tries to develop that knowledge that is being gained from the features. If the feature is being told that yes, the apple is red, yes, the feature is being marked as red. If it's banana, it's marked as yellow. So in a similar manner, the interpreting device obtains the necessary information and it interprets. Now we will be starting the testing through an algorithm, and the algorithm will give the desired output. And finally, what we can conclude, that yes, now this system has become responsive. So through this entire cyclic pattern, what the system does, the system get trains from the data set, and the system responds through testing. This is what the basic topology lies, okay, because it is basically the founder of human vision. We are thinking of human, that what we humans think, what we humans analyze through our brain, we are trying to inculcate those things through the sensing device and interpreting device, and where the input is being the data set. Okay, so a little story about computer vision. It's basically for your information. Actually, in 1996, actually at MIT, one professor asked his undergraduate student to spend the summer liking of a camera to a computer and getting that computer to describe that what it saw. Right, because from there only, what the computer saw is basically what the thinking and the perception of computer vision initiated from that date. And that problem is slightly going to difficult nowadays. Actually, what a computer is thinking, what computer is visualizing, the problems are getting much more difficult and complex, because computer is trying to analyze. And that is why machine learning algorithms are being implemented through artificial intelligence. Okay, so a brief history is, it has been initiated in the 1960s. Okay, and in the 1970s, so starting from image processing, the inception has been started on computer vision. Okay, because few of the progress of the interpreted images, such as age detection, okay, image processing, image filtering, image selection, these are all the related process that convey image processing to be an interpreted manner. And in the 1970s, these all process came up into significance. And in the 1980s, what the mathematical rigor has came up. Okay, it has been increased. And in 1990s, all the statistical analysis, okay, related to loss, related to calculation, related to evaluation, okay, and other things related to image like noise removal and other recognition of faces also came up into significance. Okay, and in 2000s, actually it has beared a broader recognition, because Python also getting updated day by day. Okay, the libraries came up. Okay, video processing starts, vision graphics and everything with the help of internet vision, they are coming up into a broader scope of range. So computer vision is basically is aimed at making understanding image, videos or any other time lapses that computer we are training to see, right? So in this image, if we focus on this particular image, what kind of scene is this? Where are the cars? So these are all questionable to the computer, and once it's being trained to the computer, then the computer can easily say, yes, this building is distant 100 meters from the car. Yes, these are the cars. The color of the car is white. White, what is white? White is the feature, nothing else. Okay, so the main components of a computer vision system are basically one is camera needed for the computer, an webcam. Okay, and a scene. Basically, particular scenes are required for training a particular data set. So that is what the data. So in case of computer vision, what we use live data set or live action. Whatever the computer see, it catches, and we try to feed that particular data set to the computer so that the scene can be interpreted in a logical and particular manner. Okay, so according to humans, what we humans can see that a particular image, our brain, in a bitmap format, right? And in computer, it is stored in the form of matrix and in pixelated format. So this pixel, basically, these are the values. Okay, they represent the intensity of any picture. Okay, it is basically in the form of 256. Okay, and from 0 to 256, it is the range. Actually, it's the if the intensity of any picture in any quantity is towards the 0, that means the area is black according to black and white image actually. And if it is towards 255, then it's white. Okay, so basically humans try to give the output directly by matching the previous features, and the computer differs in that sense that it correlates the previous data set along with the pixel format. So what the necessity of pixel format is? The necessity of pixel format is basically to match the particular feature on that particular data set and with a known feature. If the feature is unknown, then the computer will be unable to recognize that what are the features are being trained to the particular model. But if the features are previously trained and the pixel come into existence, then it will be easily able to identify that what is the status of that particular picture is. So this is what an example of human vision and against the computer vision I have just stated. Okay. So now the it is basically about the multidisciplinary approach of computer vision. Okay. Actually, I have tried to illustrate all those things actually using basically three distinct domains. Okay, machine vision, computer vision, and image processing. Okay, in each and every field, the three things they are analogous to each other. Okay, because when we consider machine vision, we will be correlating the computer graphics, right? In the field of image processing, apart from medical field, we consider imaging in any other sector, cameras, everything will be coming to image processing. And whenever it comes under intelligent systems, computer vision and its broader significance will come into elevation. Okay, in case of mathematics, statistics, while in machine learning, while performing hyperparameter tuning, while calculating the variance, while calculating the mean, while calculating the standard deviation, okay, the number of pixels, pixelated count in any images, we use computer vision to accept any image. So the first and foremost thing to accept any image through any webcam or any camera is computer vision. And for the cognitive vision part, we use machine learning. So where the machine learning can also use the rely on the access of webcam and the computer vision part, and both are significant in their way of perception, because without computer vision, machine will be unable to recognize the things. And for signal processing also, in a similar manner, the signals can be obtained from the particular images that are being extracted. So for that purpose also, we need computer vision. So in a nutshell, while recognizing anything related to image, video, or any other perception related to our modern world, while making it artificial, we will require the help of computer vision, right? Because without computer vision, artificial system cannot be developed. Without computer vision, you will be a computer will not be able to think what are the features are, and will be able to distinguish all those things, right? Because high level understanding from any digital image or videos requires a sense of knowledge that's being provided by an algorithm. So that is what computer vision does. Okay, so these are a few application areas actually for safety purpose. For an example, if we install any GUI system, then only the machine will be able to recognize that whatever cars are coming or not. And previously, by recognizing the image of any car, that system will be able to develop that the distance is being getting narrower and the accident may occur, right? So these are the major application area to reduce the traffic risks. Okay, in healthcare, in image segmentation or in any imaging technology, this computer vision seem up to be an instrumental role, right? For acute disorders or to detect any cancer or any malignant tumor, the image is being very crucial, because for considering our internal organs, we are unable to view that, right? We are unable to view what are the internal organ, what are the internal functionalities of the system of our body are. So for that case, in that healthcare, we are using the technology of computer vision to detect all those things. In the security as well, in any multi stores, in any multiplexes, we can find that, yes, that whatever the things are, they are totally white or not. As well as comfort and accessibility is a major thing. The technology of AR, VR for funning, right? Augmented reality, virtual reality, gaming, and everything else. Computer vision is being turned up to be a significant one, right? So this is basically a new paradigm of computer vision, why high megapixel smartphone camera is being used, that is able to create a massive public data set, and it is containing high quality images and videos who train the machine learning model to perform better. Actually, they are all being incorporated into an application of an Android, which application can be able to develop, and it can be accessible for low computing power applications. Okay, and it can also allow the resource of intensive tasks to analyze the visualized data, and that those data actually when we try to process in our real lives, it is basically very much costly. But in more efficient iteration and experimentation, through this customized format and computing power, accessible computing power, this task can be analyzed in a easier way. Okay, and dedicated hardwares for computer vision, they provide powerful parallel computing architectures. Okay, and to sort out more complex tasks of neural network in a much more short way and a precise manner. Okay, and new sophisticated algorithms are basically high perception. Okay, they bear accuracy for the computer vision tasks with the help of the deep learning neural networks. Okay, so the use cases of the computer vision in a broader way, in object detection. Okay, it locates the presence of any specific objects in any particular image or any video. Okay, in image classification, basically it is of categorization and labeling of image based on any specific rules. Okay, because the features only determine what the image is, right? So what the image is and what are the features that the image process is basically on image classification, because based on the classifier we will be classifying the images. Image segmentation is basically dividing a single image into various segments to separately process the relevant segments. Feature matching also is relevant to the feature engineering part, because features are the main part of a data set. Once we get a data set, we need to signify, we need to separate what are the features of a data set are. So similarity index as well as dissimilarity index, while comparing, while creating a major difference, all those things are a part of feature matching. Okay, in the edge detection part, what are the things are to find the boundary of any object by any image. Okay, and it's done by identifying the point. Okay, we use media pipe library while plotting all those things in a point in an image, and at the image brightness will change sharply through edge detection part. Okay, in the pattern recognition part is basically to automatically recognize the pattern. Okay, for an example, if any pattern is provided to any computer, then through this pattern recognition, through the predetermined algorithm, the data analysis method will be using the machine learning to automatically recognize the regularities of the data. Okay, and it can be anything from related to text, images, any pattern. It can be it can be of video as well, but it will be able to recognize those familiar patterns quickly. Okay, so basically this sensing and segmentation part along with the feature extraction is basically the phases of pattern recognition. Okay, it is a vast topic, pattern recognition, where classification to post processing is also a part to develop a particular decision that which pattern suits which one. Okay, in a facial recognition part it is also a very major topic. Okay, it is basically to identify or verify and a person using the facial features. Okay, so this is the optical character recognition. To scan images to document or text. Okay, the significant evidence of OCR software came into existence. You can see that optical character recognition, that if any handwriting is not readable, then through this method the handwriting can easily be converted. Okay, face detection. In cyber security also it is gaining a major significance. The face detection, that to develop the face of any unknown person, of any other wanted people, everything or any, and nowadays digital cameras can also detect the faces. So that is what face detection is, and it is an underlying principle of computer vision. Okay, so object recognition in supermarkets. So in supermarkets or any multiplexes, when people used to buy things through a scanner, the technology of computer vision is being inbuilt in them. What they used to do, they used to check their particular code or QR or anything that is being related with the developer, so that the particular item that is being sold is being counted into account. Okay, next come the vision based biometrics. Biometric is basically, you can see this close image. It is the most famous image of an Afghan girl. So the pattern of our iris in the eyeball, the pattern of our iris is basically vision based metrics. So this is all done with the help of pattern recognition. It is the post processing part. So how it can be incorporated so far. So this was what the vision based biometrics is all about. Okay, so biometrics, login without a password. Nowadays, we can all see in our workplaces that we have biometric attendance, right? A fingerprint can do everything. So the through the help of these fingertips, computer vision system recognizes the fingertip, the fingerprint, and those print is being recognized. So whenever that finger is being pressed to the respective scanner, the face recognition system shows that yes, this is the person and the identity has been matched. So the attendance is being recorded. Okay, the object detection in mobile phones is also a needful similar topic. Okay, so in the object detection, what the thing is, object detection, the thing is basically dealt on recognizing particular objects without any pattern. Why without any pattern? Because in object recognition, we focus mainly on object localization and image classification. Okay, furthermore object segmentation, because to identify the images in any object from or video form, we used to apply the algorithms. So for this algorithm part in cognitive physiology, we will consider any spot, people, object or scenes. And object detection is basically more precisely used to locate one or more effective targets from any data. Okay, in movie or in any films, we can find this the special effects, right? The shape capturing part. This is also bearing a major significance in computer vision. That to develop the particular shape related to the live person. Okay, to develop that particular dimension, we used to find out through that processing that what are the shape or what are the analogy or what is the dimension of our face can be. In sports also now you all can see that in a cricket or any football, that the goal line technology, right? So with the help of computer vision, the AI enabled camera helps to determine that whether the ball has crossed or not. So this is what computer vision is all about. Okay, so Yeah, actually, I discussed it due to some network issues. Actually, yeah. So in sports also, we can find a major relevance with the computer vision part, right? To analyze any particular part, and in smart cars as well, the relevance of the computer vision can be a major part. That yes, that vision is playing safely. Yeah, the car is going in a safe mode, and everything related to that. In an space and automation also, the computer vision can find a similar manner while through analyze any particular part as well as in obstacle detection as well. Okay, in medical imaging, to detect the image of any internal organs, computer vision will turn up to be a significant one. So here we can see that vision as a source of synaptic information. So in yeah, so here we can see that once a machine is being fed to the machine computer, an image is being fed to the computer, it automatically recognizes the sky, the building, the flag, and everything else. So this is what once this data is being fed to the machine, the features are being extracted and detected, and the result output is being obtained from this particular image. So computer vision versus graphics. Okay, so related to the computer vision and the graphics, 3D and 2D implies the information loss. Graphics okay, 3D implies the loss of information. Okay, and sensitivity to the errors and the need for models. Okay, and the graphics is being relating all those things into vision. Okay, so this is what the difference between computer vision and the graphics lies. To bring up the reality and to see everything as a realistic in a realistic approach, we need computer vision. Okay, and now what is OpenCV? Okay, so we will be just also covering some hands-on part with OpenCV as well. So OpenCV basically stands for Open Source Computer Vision Library. Okay, and it is a collection of various kind of predefined sets of computer vision. Okay, image processing, general purpose algorithms as well, and along with it's optimized for real-time implementation as well. Okay, and it contains a huge number of functions for image processing tasks. Okay, it contains more than 2,500 algorithms that are being developed for academic purpose as well as commercial purpose as well. Okay, industries nowadays also use computer vision for the commercialization part for real-time implementation. Okay, so now uh, I'll be just showing you some sample code that yeah, this function cv2.imread underscore color is basically a flag for loading a color image. Okay, and this is basically some important functions that we can do. And cv2.imread grayscale is basically loading some grayscale image format. Okay, and cv2.imread unchanged is basically loading the images in the given format, including the alpha channel. Okay, and alpha channel basically is about the storing transparency of the information, the higher value of alpha channel. And the more opaque the pixel is, the value of alpha channel will be transparent more. Okay, so changing the color spaces, okay, RGB and HSB. Okay, these are the most familiar terms, red, green, blue, that RGB. Okay, and how this color space is basically related to each other. So, as per the definition, so color space is basically a protocol for representing the color in a way that makes them easily reproducible. Okay, and grayscale images usually have a single pixel values, and the color images come to a key value for each pixel. Okay, height, width, and the channel. Okay, and most of the computer vision use cases they use to process the images in the RGB format. Okay, and application like video compression and the device independent storage, they are all related to color spaces, like the hue saturation value, right? That HSV color space, and the intensity and the color information they are mixed in RGB color space. Okay, and this color space and the intensity information they are separated from each other in lighting changes. Okay, so converting how to so this is basically the code to how to convert this image to HSV color space. So we will use cv2.imread function and cv2.cvt color. Okay, to convert all those things into HSV color space. And through plt.imshow function, we will be showing the images. Okay, so basically to wrap up all those things in a nutshell, we need the concept of image and array. So what are images and arrays? So they are stored in the computer in the form of array images. Okay, and the black and white images, they are stored in the form of 2D arrays, and colored images, they are stored in the form of 3D arrays. So 2D array are basically black and white images. They are having the format of x, y, that both pixel format, y both planes, and one. Okay, and three-dimensional arrays, basically they have the three channels, right? I have already told. So these three channels are represented by three, and each channel represent namely a color: red, blue, or green. And every color is a mixture of the three color in computer vision. Okay, so this illustration I think will be helpful. So 1D array, 2D array, and 3D array. Okay, so next come to image segmentation. So image segmentation is a task of classifying every pixel in the image to some class. Okay, so to prepare an object and we need an instance of a class. So to classify each pixel as a foreground or a background, we need image segmentation, and it is used to extract the relevant parts from any images. Okay, it is related to region segmentation, right? It is extracting a tree, this bark from this entire image. Relating those things, image filtering and enhancing, right? Linear filter, we can use convolution. Okay, for edge detection, we can use the feature extraction part. Okay, the image smoothing can be done by removal of the noise. There are various kind of noise: saltpeter noise, Gaussian noise, etc. There are various kind of noise. Okay, so edge detection is basically at the points in an image where the image brightness changes as sharply. Okay, and they lead to the discontinuity in the depth of any image, depth and surface orientation, because once we zoom, right, the depth loses and the pixel will be disappearing. So these discontinuity will be leading more these edges, and the material properties will be changes along with the variations. Okay, and these edges are very useful features of an image that can be used to different applications like classification of objects in image localization, deep learning models to detect the features present in a particular image. And this is basically how to convert this image. Okay, cv.cv to convert is basically the Python code, how we can convert all those things. So cascade classifier, similar to image processing part, all these terms basically they are a very vast topics, but I am just covering up all those things in a nutshell. That it supports to here cascade based object detection. Okay, and they are machine learning classifiers that calculate different feature like edges, lines, etc. in any image. Okay, there are various kind of frames, and a train classifier for different objects like faces, eyes, they are available in the OpenCV. Okay, so this is the process, that entire face recognition process. I have just those covering up all those things in the previous slide. So in a nutshell, after covering up image classification, when we will be just coming up with the face detection part, what the OpenCV does, OpenCV will be creating a cascade classifier, and it will contain all the features of a space face. It is inbuilt in them, and it will read all the image and the features in a file. Okay, and the numpy array in the OpenCV, they will search for the row and column values of the face in the ND array, and finally they will display the image in a rectangular face box. Okay, where each pixel will be identified. So object detection is basically in the process of finding a real world object instances. Okay, and it allows for the recognition and localization of various kind of multiple objects within any particular image, and it's more commonly used in application like image retrieval, security, assistance, etc. Okay, so it is basically illustration. In the basic concept, you no need to cover up all those things. Okay, for an example, from multiple layer of convolution and pooling, we have several kind of hidden layers. Okay, and using back propagation or front propagation, we will be doing the feature mapping. Okay, after the feature mapping, the classification it comes and the object class is being trained, and according to regression of the classifier, the box coordinates are placed and the different pixels are being done. Okay, related to that, image AI is basically a Python library. Okay, that lets all the programmers or project developer to do the application that is being related with computer vision. Okay, so this was all about the basic depiction of what the theory part all meant. Okay, so now I will just present one Python file while I am just showing you that what are the demonstration of Python is there. So initially, I have imported several libraries. Okay, for array operations, NumPy is being imported. Matplotlib for plotting several kind of graphs. Pillow is from visualizing and images. Okay, so initially I have loaded the images. You can see this is the images. So now image array, right? To convert all those things, we have converted it into NumPy array, and you can see this array. Okay, and at the last we will be getting the data type. Yeah, the data type is integer. Okay, now I have just checked the shape of an array. It's basically three. Through this rotate function, I have rotated this image 90 degree. So this all falls under the category of image processing. Okay, and the image is being rotated. And in the next step, let me scroll. Yeah, in the next step, I am converted it into black and white. You can see the color is being changed from that on normal RGB format. We can get the black and white format. Okay, and this is quite interesting. Okay, that it is basically a palette image. Okay, you can see, and this is the syntax of writing the palette image code. Okay, so palette pill image adaptive. Okay, and once you increase the number of colors, the image will be getting more prominent. Okay, so this is what palette seems like. Palette. Okay, image dot adaptive colors and 8. And now the image is being resized once again. I have just resized this image once again, and and after that, with the help of image filter from pillow library, I have blurred the image. Okay, you can see the image is being blurred in the background. Okay, so this is what blurring turned up. And after that, I initiated with the edge detection part. Okay, so in the edge detection part, this is the syntax of writing the edge detection, and in the pld.im show, I have plotted this image in the x-axis and y-axis plane, and bgr to rgb, the conversion is being done here. Okay, and the array is being represented. And finally, the image is being shown in again the format of rgb that is being converted. Okay, and 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 another time we have converted the bgr to hsv format. Okay, so this is what the hsv image look like once we have converted. And now what the hsv image will look like, it is being placed in the output part. Okay, so this image that I was talking about in this part, this edge detection part, this edge detection is quite similar to this hands-on part. Okay, so up till this was all about the basics of computer vision. Okay, that how this computer realize how this thing is being done, working with images. So this is basically a sample demo that how we work with images. Okay, so till now, any query, anyone, you can post in the chat.
Thank you. It was really a nice session from your side. And thank you guys for being here even on the Saturday. I'm sharing the feedback link on the comment section, and you can surely post your views about this session. And also, you can post what you would like to hear from us the next session about. And if you want to state anything, you can post it on comment, or else uh, you may continue enjoying your weekend. Thanks for being here. Thank you, Mr. Utsav, and thank you, everyone.
Thank you so much.
Yeah, thank you.